Welcome to a lesson with Dr. Powell. Let's take a look at an example of finding the maximum or minimum of a quadratic function. This time, let's look at negative 5x squared plus 10x minus 2. So first, we complete the square to put it into a nice form for seeing what kind of transformation it is of y equals x squared. Factor the negative 5 out of just the x squared and the x part so that in these brackets, the coefficient of x squared is just 1. That enables us to be able to do our normal technique of replacement with a square and then n plus something. So here we think negative 5 times what will give us 10x? Well, it looks like it'll be a minus 2x. We can check it. Negative 5 is that. Okay, so we're good so far. Now we're just going to focus as if we're just living inside these brackets here and just think about what's happening in here. We make a replacement. And maybe just rewrite these brackets. Make a replacement inside here of x minus 1 quantity squared, just 1/2 that negative 2. In that process, we've added 1, which is just negative 1 squared. But to offset that, we need to put a minus 1 here. Then we're almost done. Then we distribute this negative 5 into both pieces. So we end up getting negative 5 quantity x minus 1 squared. And then negative 5 times negative 1 is plus 5 minus 2. So we end up getting y is equal to negative 5 quantity x minus 1 squared, and then plus 3. This is the same quadratic function, but written in a nice standard form is what it's called, to see how this has been transformed. Okay, now this helps us figure out what the max or min of this function is. So let's think about this. Y equals x squared has a vertex of 0, 0. Its minimum is 0 at x equals 0. Y value is 0, that's the what, and x equals 0, that's the where. But how has it changed in the transformation? Well, at least for the x values, to figure out where it occurs, max or min, we notice that it's going to be at x equals 1. Because that's what the x value is going, because that's the x value that we get from this transformation, because we're adding 1 to all the x values, and we add 1 to that 0. So 1 will be the where of the max or min. Now, what about, is it a max or min? Well, let's think about the y transformations. The y transformations are, you take this bit right here, and you first multiply by negative 5 to all the y's, and then you add 3. So if you started at 0, you would multiply by negative 5 is just 0, and then you add 3, you just get 3. Notice that we can just read that off. What makes this part 0 is 1, and then this plus 3 out over here, that's just the y coordinate of the vertex. We can see that right here because we're just, anything times 0 is just 0. So it's just that. So really, this would be the what then. But then we have to ask ourselves, is this a max or min? Well, think originally it's a minimum for y equals x squared because it's the lowest y value. But then we reflect. See this reflection here by multiplication by a negative here in the y? I mean, so the y values, and really that's the only thing that's important here for reflection is just the y values in this case, because that's the only thing that can change a minimum to a maximum. And that's exactly what we have. We have a reflection. So that means this is the where and the what of what, not the minimum, but the maximum. So we know that the max of this quadratic function is equal to 3. And where does it happen? At x equals 1. Thanks for watching.